Our planet holds countless secrets, buried deep within its rocky layers. Sometimes a chance discovery can rewrite a chapter of our own human story. This is what happened in 1960 in a place called the Petrolona Cave in northern Greece. This cave, known to locals as the Cave of the Red Stones, is a labyrinth of passages and chambers, decorated with spectacular stalactites and stalagmites. A group of local villagers, searching for a water source, ventured into its depths. What they found was not water, but something far more extraordinary. It was a fossilized human skull, encased in the stone wall, looking as if it had grown from the rock itself. The skull was not lying on the cave floor, waiting to be picked up. Instead, it was fused into the wall by a thick layer of calcite, a mineral that forms over thousands of years as water drips through the cave. Imagine a candle, with wax dripping down its side, slowly covering everything in its path. In a similar way, this ancient skull had become part of the cave's very structure. It was a breathtaking sight, a ghostly face from a forgotten time, staring out from the stone. The villagers knew they had stumbled upon something of great importance, a message from the distant past preserved in the most remarkable way. Getting the skull out was a delicate and difficult task. It had to be carefully chiseled away from the rock that had held it for so long. The men who found it were not scientists, but they understood the need for care. They worked for hours, slowly freeing the fossil from its rocky tomb. When it was finally liberated, the world could see it clearly for the first time. It was an almost complete skull, with a strong brow ridge and a large face. It was clearly human, but not quite like any human living today. This was the beginning of a great scientific mystery, a puzzle that would challenge researchers for decades to come. The discovery immediately sparked immense excitement and debate. Who did this skull belong to? How did it end up sealed inside a cave wall? And most importantly, how long had it been there? The cave had also preserved the bones of many ancient animals, including cave bears, hyenas, and lions, which hinted at a very old age. The scene was set for a long and fascinating investigation. Scientists from around the world turned their attention to this remote Greek cave, hoping to understand the story of the individual who has become known simply as the Petrolona Man, a silent witness to a world very different from our own. Once the skull was brought into the light, the real challenge began. Scientists were faced with two fundamental questions. What kind of ancient human was this, and precisely how old was it? The initial examinations were confusing. The skull possessed a curious mix of features. Some traits, like its large brain capacity, seemed relatively advanced, similar to early Neanderthals or even our own species, Homo sapiens. However, other features, such as the massive brow ridge and a broad projecting face, appeared much more ancient, reminiscent of an older species known as Homo erectus. This combination of old and new traits made it incredibly difficult to place within our family tree. The question of its age was even more contentious. Early estimates varied wildly, a testament to the difficulty of dating such a find. Some researchers, looking at the primitive features, suggested it could be over 700,000 years old. Others, focusing on the more modern traits, argued for a much younger age, perhaps closer to 160,000 years old. This huge disagreement, spanning more than 500,000 years, created a scientific deadlock. The skull's unique position, embedded in the cave's calcite layers, should have been a clue, but the dating methods available at the time were not precise enough to provide a definitive answer, leading to decades of scientific debate. This uncertainty led to the skull being classified in various ways over the years. Some scientists labeled it as an early Neanderthal. Others proposed it belonged to the species Homo heidelbergensis, a group considered to be the common ancestor of both Neanderthals and modern humans. A few even argued that it represented a unique, distinct species of human altogether. Without a reliable date, each argument was based on interpreting the physical shape of the skull, which can be subjective. The Petrolona skull became a famous, yet frustrating fossil, a key piece of the human origins puzzle that nobody could quite fit into place. The scientific community needed a better tool, a more reliable way to read the calendar hidden within the cave's minerals. The disagreements were not just academic arguments. The skull's true age was crucial for understanding the story of human evolution in Europe. Was it an ancestor that arrived before the Neanderthals? Or was it a contemporary, living alongside them? Answering this would require a leap forward in technology, a method that could look directly at the atoms of the rock that had so perfectly preserved this ancient individual and force it to reveal its long-held secret about time. The breakthrough came from a field of science that studies the very building blocks of matter. To solve the riddle of the Petrolona skull's age, scientists turned to a powerful technique called uranium-thorium dating. This method works like a very slow, very precise atomic clock, hidden within the minerals of the cave itself. It relies on the natural process of radioactive decay. When water seeps through limestone rock to form stalactites and stalagmites, it contains tiny, trace amounts of the element uranium. This uranium is trapped within the growing layers of calcite, the very material that encased the skull. It is the starting point for our clock. Now, uranium is not a stable element. Over immense periods of time, its atoms naturally and predictably transform or decay into other elements. One of the elements it decays into is thorium. The crucial detail is that when the calcite first forms, it contains uranium, but virtually no thorium. So as soon as the rock is formed, the clock starts ticking. The trapped uranium atoms begin their slow decay into thorium atoms. By carefully measuring the ratio of uranium to thorium in a sample of the calcite, scientists can calculate exactly how much time has passed since that layer of rock was formed. This technique is incredibly useful for dating cave formations and the fossils found within them. For the Petrolona skull, this meant scientists could take tiny samples from the layers of calcite that had formed directly on top of the skull. This would not date the skull itself, but it would tell them the minimum age. The skull had to be at least as old as the rock that grew over it. It was like finding a newspaper lying on the ground, covered by a layer of snow. The newspaper must have been there before the snow fell. This method provided a much more direct and reliable way to constrain the fossil's age than simply studying the animal bones found elsewhere in the cave. When researchers applied this modern technique to the calcite layers encrusting the Petrolona skull, the results were astonishingly precise. They determined that the layers covering the skull were approximately 200,000 years old. This finally provided a solid scientific benchmark. It meant the skull was older than that, resolving much of the earlier debate. The individual had lived and died more than 200,000 years ago, placing it firmly in a critical period of human evolution known as the Middle Pleistocene. The atomic clock had spoken, ending decades of speculation and allowing a clearer picture of this ancient human to emerge. With a reliable age of over 200,000 years, scientists could now place the Petrolona skull into the broader context of human evolution with much more confidence. This age positions it in a fascinating time, a period when the ancestors of Neanderthals were spreading across Europe. The skull's blended features finally started to make sense. The primitive aspects, like the heavy brow, connected to older ancestors like Homo heidelbergensis, while its more advanced traits like the large brain case show it was on the evolutionary path that would eventually lead to the classic Neanderthals. It is a snapshot of evolution in action. This is where a comparison to another famous fossil becomes incredibly important. Far away in Africa, a skull known as the Kabwe skull, found in what is now Zambia, shows a remarkable resemblance to the Petrolona skull. The Kabwe skull, also possessing a mix of ancient and more modern features, is from a similar time period. This suggests that around 200,000 to 300,000 years ago, there was a widespread population of these intermediate humans, often classified as Homo heidelbergensis, living across both Africa and Europe. They were the common ancestors from which different human lineages would diverge: Neanderthals in Europe and our own species, Homo sapiens in Africa. So what have we learned from this face in the stone? The Petrolona skull is no longer seen as a confusing anomaly, but as a vital link. It represents a crucial transitional form, a window into the time just before the familiar figures of Neanderthals and modern humans took their final shape. It shows us that our family tree is not a simple straight line, but a complex branching bush with many related forms existing at the same time. The Petrolona individual was part of a diverse human world, one that we are only just beginning to fully understand through these remarkable fossil discoveries. And yet, many questions remain. Was the Petrolona individual a direct ancestor of the later Neanderthals, or part of a related but separate lineage that eventually died out? How did this person die inside the cave? Was it an accident, or was the cave used in some ritualistic way? The skull itself cannot answer these questions. Each discovery, while providing answers, also opens up new avenues of inquiry. The mysterious skull from the Cave of the Red Stones remains a powerful symbol of our deep past, reminding us that the story of humanity is still being written, one fossil at a time.